Hello, today we're going to take a look at example 3.1, present and future value of lump sums. So what we're looking at here is the time value of money. We're trying to figure out what is a given amount of money going to be worth in the future if compounded at a specific interest rate. Most of you probably have some experience with a savings account or other type of investment in which we are paid a percentage of interest. Interest is the charge to use someone else's money. When we invest our money, such as a savings account, our bank is paying us for the use of our money. So compound interest is a wonderful thing, and as we see in problem one here, problem one asks us if we were to invest $50,000 at 5% interest for 10 years, how much is our investment to be worth at the end of the period? Well, luckily for us, we can access what's called the future value table, and I had this uploaded to this assignment, and it's in content for this course also. But this is very useful. But very useful to compute the future values of lump sums. In this particular case, we have a lump sum of $50,000. We're not going to be adding any more money to it. We just simply have a lump sum of $50,000. We're going to be adding interest to it, but that's it. So, and the two pieces of information we need to know are the interest rate and the time period. So if I look here, 5%, 10 years, we see a factor of 1.629. And you simply, to compute your future value, you simply just take the lump current value times the chart value equals the future value. Your answer will always be a bigger number, obviously, than our starting number. We have interest that's being computed here and compounded. So therefore, we're going to have a larger sum at the end. And it's quite amazing how interest can build. This is the wonderful thing about investing money. We can make a lot of money on the money that we already have. Question 2. If we were to invest $15,000 at 8% interest, what would it be worth in 30 years? Okay, so we go over to our future value table. 8%, 30 years. Make sure I'm on the right column here. 10.063. Take that $15,000 times 10.063. We can see that the final value is $150,945. So, yeah, our initial investment multiplied by 10. Why did it get so big? First of all, we have a good interest rate here of 8%, but the biggest key is 30 years. We let this money accumulate interest for a long time. That's why we were able to build such a huge dollar figure here. Number 3 is a little bit different problem. Just threw that out there so you folks see if you folks can remember your algebra and solve a problem. In this case, $20,000 is invested, and 6 years later it becomes $33,542. What percent interest was earned on the investment? We just simply set up an algebraic equation and solve for the unknown. Here we know the present value and the future value. We don't know what the percent interest was. We do know it was for 6 years though. So what we do is we don't know the chart number because we don't know the interest rate. So $20,000 times n equals the future value of 33,542. We solve for n by dividing 33,542 by 20,000 to get a 1.6771. That would be n. N's our chart number. Okay, in the chart number, we know 6 years. So to figure out the percent interest, we just go along the row. 1.6, right there it is. 1.677 correlates to 9% interest. Okay. Money was invested. Okay, now present value numbers, present value chart. In the present value examples, what we know is what the future value will be, and what we need to figure out is what our present value or beginning value is. So money was invested at 8% for 10 years, and the end result was 25,000. What amount of money was originally invested? Well, just like the other problems, we look at the chart. 8%, 10 years. Right here, 8%, 10 years. 0.463. So we take our future value, 25,000 times 0.463 gives us our present value of $11,575. Our present value will always be less than our future value. Okay? Farmer Fran is going to buy a savings bond. The end result is $10,000 in 10 years. What can we pay for this bond today if we want to have a return of 6%? 10 years, 6%. Here's 6%, 10 years, 0.558. So we just take our end result, 10,000 times 0.558. We get an answer of 5,580. So hopefully that makes sense. You could also use this chart as a discounting chart. For example, if you wanted an item, an asset, for example, to go down 10% a year for 10 years, you could use the same number, and that would tell you if the asset decreased in value 10%, what it would be worth in 10 years. So anyway, hopefully this example will help you to complete the worksheet 3.1. And as always, if you have any questions, please feel free to drop me an email, give me a call, or stop by my office, and I will do my very best to help you out with any questions. Thanks and good luck.